All right, so we'll try to finish up the problems on the review. So I think I stopped at 19 on part one of this. So here we'll pick up 20 on our review. So number 20, we're finding the double angle of the three trig functions, sine, cosine, and tangent. And we start off with cotangent equals 3 and lies in quadrant 2. So I will try to draw that situation, which I like to do. So I always start off with drawing the x and the y axis, and then I'll draw an angle that lies in quadrant 3. Right here, I'll turn it into a right triangle by going to the x-axis. I got theta here. And for cotangent, it says cotangent of theta equals 3. And I'll go ahead and write 3 over 1. So for tangent of theta is y over x. So cotangent would be the opposite, x over y. Or I probably should say, because I think this is what we've been doing, TOA is O over A. So cotangent would be the reciprocal, which is A over O. So my adjacent side would be 3, and my opposite side would be 1. So I want to find the hypotenuse of this triangle, which I think will be root 10. So let's see. Let's go right here. So I'll do a squared plus b squared equals c squared. 3 squared plus 1 squared equals c squared. 9 plus 1, c equals the square root of 10. And I can't reduce that or simplify that at all, so I would just leave that as the square root of 10. So in order to do these double angle formulas, I need to know all three of the ratios for each one of these trig functions to be able to do each formula. So let's write what cosine is. I think I was using a pen. So I got cotangent, but I really don't use that as I find these. Let's do cosine of theta. Cosine is A over H. Cosine is O. And this should be -3, and this should be -1, because we go left to 3, and then we go down 3. And in the third quadrant, I know that x and y is positive, which made cotangent and tangent positive. Sorry, I think I said positive. These two are negative in the third quadrant, x and y. So the two negatives give me a positive cotangent or a positive tangent. But these other functions should be negative. So the adjacent side, which is right here, opposite hypotenuse, adjacent is -3 over root 10. Sine theta, O over H. Opposite side is -1. Hypotenuse is root 10. And then tangent of theta, O over A. The opposite side is -1. The adjacent side is -3. So this will come out to just be, 1 over 3. All right, so let's do the double angle for cosine to start off. So following this formula here, 2 times sine times cosine. So sine was -1 over root 10, and I need this times 2, times cosine. Cosine was -3 over root 10. So I just multiply across the top. I got 2 times -1, which is -2 times 3. Should be -6. Sorry, +6, because the two negatives make it positive. Over square root of 10 times square root of 10 is the square root of 100, which comes out to be just 10. So 6 over 10. I can reduce that to 3 over 5. And I actually just did sine. Just caught that. So I actually did the double angle for sine, sine times cosine. So we just did sine. I wrote cosine, but I didn't do cosine. I did sine. So let me change this. Glad I caught that now. So we just did sine. Now let's do cosine. Cosine double angle is cosine squared minus sine squared. So cosine's ratio is -3 over root 10 squared minus sine squared, which is -1 over root 10 squared. So -√3 squared is just a 9. And remember, when you square this fraction, you square the top of it and the bottom of it. So root 10 squared is 10 minus -1 squared is +1 over root 10 squared is 10 also. I can do 9 minus 1 and I get 8 over 10, which simplifies to be 4 over 5. And finally, we'll go and do tangent. Tangent double angle. So I'll do 2 over tangent theta divided by 1 minus tangent squared theta. So we found the tangent is 1 over 3. So I will do 2 times 1 over 3 divided by 1 minus 1 over 3 squared. On this one, we multiply 2 times 1 to get 2 over 3 divided by 1 squared is 1 over 3 squared, which is 9. In order to subtract these two, I need to get a common denominator of 9. So I would multiply 1 by 9 over 9, and I'll rewrite it that way. So what I get is 2 over 3 divided by 9 minus 1, and they both have a denominator of 9, so I put them together. 9 minus 1 is 8. 2 over 3 divided by 8 over 9. And then I will multiply by this reciprocal. So 2 over 3 times 9 over 8. 3 goes into 9 3 times. I can divide 8 by 2 and I get 4, which leaves me with 3 over 4. All right. So going to number 27, final ones, use the half angle formulas to find the exact value. All right, so in these first two questions, we start off not knowing what the half angle is, but it gives us ratios for theta. So we'll use that, we'll draw our triangle, and we'll find our other ratios and be able to use the formulas. On 31 through 34, we'll just double the angle and then we'll use the formula. So these last four are pretty straightforward. 27 and 28, we got a little bit of work to do to get the exact values, but once we figure out what the other exact values are, we can then go from there and then just solve them as we normally would. All right, so 27, we want to find sine, cosine, and tangent's double angle, and we're given that tangent of theta equals 8 over 15. And then it gives us an interval that the angle lies within, where theta is greater than pi, but it's less than 3 pi over 2. So we got to figure out which quadrant this angle falls in. So it doesn't tell us like it's in quadrant 1 or it's in quadrant 2, but it gives us an interval. So if I do a little sketch of just what you would see on the unit circle, I know this is 0, pi over 2, just pi, 3 pi over 2, and then I finish my cycle at 2 pi. It tells me that this angle is greater than pi, so it's larger than this measure, but it's less than 3 pi over 2. So it's got to be somewhere in this quadrant. Now, I don't know exactly where, and I don't need to know where. I just need to know which quadrant it's in. All right, so I draw the angle, I turn it into a right triangle, and then I use this ratio to label the sides of the triangle that I can find. So we start off with tangent, and tangent's ratio is opposite over adjacent. So I'll label my triangle with those two sides that I know the value of. The opposite side, opposite of theta, is 8. And then the adjacent side next to theta is 15. Let's find the missing side of this triangle using Pythagorean theorem. A squared plus b squared equals c squared. 8 squared plus 15 squared equals c squared. 8 squared plus 15 squared equals 289. And then I will see if this is a perfect square root, and it is. So that comes out to equal 17. So I guess just to be clear, we had c came to equal 289, and then we took the square root of that to find that c equals 17. So this hypotenuse is 17. So if I'm thinking about my sides, since I'm in the third quadrant, the x is negative and the y is negative as well. And then if I think about cotangent, if both of these were negative, we would get a positive fraction, which is what we get. So these two numbers are negative. When I go and write my other functions, let's do cosine of theta. I get a over h, which is negative 15 over 17. And then sine of theta, opposite over hypotenuse, is negative 8 over 17. So I got my three ratios I need to be able to use this formula. Okay, so I got all my exact values to be able to use this formula. Now, when we use these two, we need to decide of the sign. So just remember, you choose the appropriate sign depending on the quadrant of theta over 2. In this third quadrant, we only have theta. All right, so this isn't where the half angle is. I actually will do half of this. So just kind of thinking about it, half of this angle will be in the second quadrant. And I'll give you some angles that are in the third quadrant and we'll do half of it. So let's say this was 225, which is greater than 180 and in the third quadrant. If I did half of that, it would be 112. Sorry, 112.5, which is in the second quadrant. If I did 260, which is in the second quadrant, and divided it by 2, 130 is in the second quadrant. If I did 181 and divided it by 2, it's a little bit bigger than 90, but it's greater than 90, so it'll be in the second quadrant. Angles here, the half angle is in the second quadrant. If you went to quadrant 4 and found some half angles, they would also be in the second quadrant. If you start off with theta angles in quadrant 2, the half angle will put you in the first quadrant. All right, so with this interval, the way I would find this is I would divide all these pieces by 2, because what I want is theta divided by 2. In order to figure that out, I'll divide my interval by 2. So then I'll write what I got. I got theta, the angle, is greater than pi over 2, which is 90. So I know it can't be in the first quadrant because it's got to be greater than this 90. And it's less than 3 pi over 2 times 2, which is 4. That angle is in the second quadrant. So this is where 3 pi over 4 is. This is where pi over 2 is. My angle is somewhere in this interval, in quadrant 2. So I'll make a little note saying the half angle theta over 2 is in quadrant 2. So you always find your sign by looking at the half angle, not of the doubled angle, but the half angle. All right, so let's do these formulas. First one we'll do is sine theta over 2. So I'm right here. First I have to choose, is it positive or negative? So in the second quadrant, the half angle will come out to be positive for sine because sine is positive in the second quadrant. Let me grab my unit circle to show you. So in quadrant 2, all of the y values which represent sine are positive. So quadrant 2, I would choose the positive option. And then I have 1 minus cosine of theta. Cosine is negative 15 over 17. So minus negative 15 over 17. All that's just following from the formula. Okay? When I subtract the negative, this will make it positive. So I'll go ahead and change my signs. And then I want to get this to be just one fraction. So I need to change how this one looks. I need it to be 17 over 17. So then I can subtract these two values. So 17 over 17, that's my 1. And then 15 over 17 is what I already had. Since both of them now have a denominator of 17, I just put them together. Then this is all over 2. 15 plus 17 is 32, I think. And then I'll also just multiply the denominators together since this isn't a fraction in the bottom, and I get 34. So I've got the square root of 32 divided by 34. Then I can reduce these since both of them are under the radical. They both are divisible by 2. So 32 divided by 2 is 16. 34 divided by 2 is 17. Sixteen is a perfect square. Square root of 16 is 4, so I can write this as 4 over root 17. And then I can't leave it like that, so I have to rationalize it by multiplying the top and the bottom by the radical on the denominator. So I multiply the top and the bottom of this fraction by the square root of 17, and I get 4 times the root 17 over 17. Let's do cosine. Cosine half angle. That's where I do cosine squared. I'm sorry, I'm thinking about double angle. So I'll just do cosine plus 1 divided by 2. So I got to choose my sign, positive or negative. Remember, my half angle is in the second quadrant. In the second quadrant, cosine is negative. So I'm going to choose to get a negative when I finish inside my radical. So I'll do the negative square root of cosine theta. Cosine is negative 15 over 17 again, plus 1 over 2. So just like last time, I'm going to get a common denominator for 1. So I'll rewrite 1 as 17 over 17. So negative 17 plus, sorry, 15. I don't know why I wrote 17 there. It says 15 clearly. So negative 15 plus 17 over 17, all divided by 2. All right, so negative 15 plus 17 is 2. Then on the bottom, I'll go ahead and multiply 2 times 17 to give me 34. So what I got is 2 over 34, all inside the radical, and the outcome is supposed to be negative since I'm in the second quadrant. So I can reduce these. If I divide both the top and the bottom by 2, I get 1 over 17. The square root of 1 is 1, so 1 over root 17. When I rationalize it, I multiply the top and the bottom by 17, just like I did right here. And the answer I get is the square root of 17 over 17. And it should be negative. All right, so just recall whenever you do tangent, you could do sine over cosine. So you could take these two answers and you could do 4 root 17 divided by 17. And you can divide that by cosine's answer, which is negative root 17 over 17. Once you keep change flip and cancel out everything, you should get what we're about to get when we do tangent half angle. So let's see if I got enough space to do that. We're going to do tangent of theta over 2. And we'll see what we get. So for tangent, you got 3 different formulas you could use to find this exact value. Like I say, I like to use this one, so I'll be using this one, but you could use all 3 of these. If you do the one with the square root, just because the square root only limits it to positive values, you will need to decide should it be positive or negative. In the second quadrant, tangent's negative, so you would pick the negative outcome if you did this one. I'll do this one, and since there's no radical and it has a cosine and a sine ratio in it, the negative and positive will sort itself out. So I'm going to do this one. So I got 1 minus cosine's ratio, negative 15 over 17, divided by sine's ratio, which is negative 8 over 17. All right, subtracting a negative, so this will become positive. And I'll convert 1 to have the same denominator as this fraction. So what I get is 17 plus 15 over negative 8 over 17. I'm sorry, I forgot 17, didn't I? So this is the top fraction of my numerator, so this should be over 17. And then this whole thing should be divided by negative 8 over 17. Negative 15. Something feels off. I get my signs right. Yeah. All right. So 17 plus 15 is 32. 32 over 17 divided by negative 8 over 17. I'll keep top. I'll multiply by 17 over negative 8. And what I get is 17's cancel. What I get is 32 over negative 8, which comes out to equal negative 4. Now, if I think about it, if I would have did sine over cosine, I would keep this, I would flip this one to 17 over root 17. The 17s would cancel, the root 17s would cancel, I would be left with the negative 4. And then this would be my answer as well. All right, so that was number 28. That was number 27. Let's do 28. So 28, similar setup. I'm given secant of theta equals negative 3. And pi over 2, theta is greater than that, and theta is less than pi. So this looks like quadrant 2. Right, if I draw it, this is pi over 2, this is pi, this angle is somewhere over here. All right, so secant is cosine's reciprocal. I know that cosine of theta is chi TOA, chi A over H. So secant would be H over A, where A is just 1, because -3 divided by 1 is -3. So the adjacent side would be 1, and the hypotenuse would be 3. For opposite, I gotta find it. Let me write this, adjacent hypotenuse. And since I'm starting at the origin and going left 1, the 1 will be negative, which made this -3, which made this -3. So it would have been 3 divided by -1 to get secant. All right, so let's find the missing side. A squared plus B squared equals C squared. A is -1 squared plus B squared, which is what I want to find. The hypotenuse squared would be 3 squared. That's 1 plus B squared equals 9. If I subtract 1 from each side, I'd get 8, and then I do the square root of that. This reduces to 2√2. All right, so that's this missing side. 2√2. All right, so let's write our other ratios. So we need all 3 to do all of these problems. So sine of theta would be opposite, which is 2√2 over the hypotenuse. Cosine would be adjacent over hypotenuse. And then tangent would be opposite over adjacent, which would be just -2√2. All right. So let's see where this half angle would be. And since it's in the second quadrant, any half angle from the second quadrant will go to the first. Let's check that by dividing this whole interval by 2. So we want theta by 2. We want theta divided by 2, the half angle. So I'll divide this term by 2. That'll give me pi over 2 times 2, which is 4. And theta has to be less than pi divided by 2, which is the 90. So this is between 45 and 90. So if I just kind of sketch that, 45 is here, 90 will be here, so this angle will be somewhere in the first quadrant between this interval. So all of my options I'll choose will be positive, because this angle's in the first quadrant and all the functions are positive in the first quadrant. All right, so let's do the half angles. First up, sine. Sine half angle, theta divided by 2. Since we're in the first quadrant, we're going to choose the positive version of it. And then I'll do 1 minus cosine, which we said was -1 over 3, divided by 2, all inside the radical. All right, so subtracting the negative makes it positive. And then I'll go ahead and give 1 a denominator of 3. So what I'll get is 3 plus 1 over 3 divided by 2. 3 plus 1 is 4 over, and then I'll go ahead and do 2 times 3 with my denominator, so 4 over 6 in the radical. I could reduce this now. I also could do the square root of 4. Let's see, what do I want to do? If I had square root of 6, let's just go ahead and reduce it. So I can divide both of these numbers by 2, and that would give me 2 over 3. So square root of 2 over square root of 3. I need to multiply the top and the bottom by the square root of 3. And I get root 6 over 3. All right. It's positive, yep. All right, cosine's half angle. I'll choose the positive option because I'm in the first quadrant, and I got cosine of theta. Cosine's ratio is -1 over 3. Then I'll add 1 to it, and then I'll divide that number by 2. So my setup's like this from the formula. I need to give 1 the same denominator as this 3, so that would give me -1 plus 3 all over 3, all divided by 2, all in the radical. So what I had was -1 over 3, that's this part, and then I converted 1 to be 3 over 3. They both have a denominator of 3, so I just put them together. -1 plus 3 is 2, and then I'll multiply the 2 denominators to get 6. And then I'll rewrite how this looks. Root 2, actually I can reduce this. Yeah, I should probably reduce this. They both are divisible by 2. If my whiteout chooses to work. All right, so 2 divided by 2 is 1, 6 divided by 2 is 3. So the square root of 1 is 1. I got 1 over root 3. When I rationalize it, I get root 3 over 3. All right, last but not least, tangent. So for tangent, I could do sine over cosine. And just so we see this way, that would be root 6 over 3 divided by root 3 over 3. So I'm going to go ahead and just keep the first thing. I'm going to multiply by the reciprocal of the second part. So these would cancel. Then I'd have root 6 over root 3. Let me write it like this. And that cancels to be root 2. So if we did it that way, we should get root 2. Let's use the formula and see if we get the same thing. So let's do tangent's half angle formula. So theta over 2 equals 1 minus cosine. Cosine was -1 over 3 divided by sine, which was 2 root 2 over 3. It's like all the other ones, I need a common denominator here. Since I'm subtracting a negative number, it'll become positive. And then I'll rewrite 1 to be 3 over 3. So that will give me 3 over 3 plus 1 over 3, all divided by 2 root 2 over 3. 3 plus 1 is 4. All right, so I'll keep this first part. I'll multiply by the reciprocal of the bottom. So I'll multiply by 3 over 2 root 2. 3's cancel out, and I can divide 4 by 2. So the 2 cancels out to be just 1. What I'm left with is 2 over root 2. Sorry, that little slash. I was about to go ahead and just rationalize it, but I need to show that. Sorry. Right, and then when I multiply by root 2, I get 2 root 2 over 2. And then the 2's cancel. So, as we predicted, I get root 2. So if you do cosine and sine, if you find these values previously, you can just go ahead and just do your quotient identity, and you get the same answer we get as if we use this formula, which is just the square root of 2. All right, these are the harder versions of those. It just takes a little bit more work to find those exact values. Let's finish the study guide with these last 4 problems. So we just start off with an angle that we don't know the value of. My first step will be to double it, and then I'll use these formulas we were just using. So let's find cosine of 22.5 degrees. And this is number 31. So obviously 22.5 isn't on my unit circle, so I don't know where that's at, or I don't know that exact value. I know where it's at, I don't know that exact value. So to get me started, I'll double 22.5 times 2, and I get 45. Now, in all honesty, I know what cosine of 45 is. Cosine of 45 should be root 2 over 2. Let's go ahead and put it in the formula and see if that's what we get. All right, so I used the formula. I needed to choose, is it positive or negative? And remember, I choose the half angle. So both of these values are in the first quadrant. I focus on the half angles where that angle is. In this case, cosine of 22 should be positive because 22.5 degrees is in the first quadrant. So I choose the positive outcome, and then it would be 1 plus. Sorry, I'm doing it all backwards. Should be cosine over 2. So it should be 45 over 2, which is how we get back to 22.5. I'm choosing the positive option, and then I have cosine's value, and I'm doing cosine of 45 degrees plus 1 divided by 2. Cosine of 45 is root 2 over 2 plus 1 over 2. Need a common denominator of 2 over 2. So I get root 2 plus 2 all over 2 divided by 2. I'll get my denominators together since the bottom denominator is just the whole number. So I'll do 2 times 2, and my denominator will be 4. So root 2 plus 2 all over 4. And then I can do the square root of 4, which is just 2. So what I finish with is root 2 plus 2, still under the radical, but since I did the square root of 4, I can take that part out of the radical. And what I get is square root of 2. And I don't know if I said we just know what the square root of 45 is, but I forgot we were doing the half angle. So we actually wanted to find cosine of 22.5, which isn't the same as cosine of 45. So I think I might have said that a little earlier. If I did, just ignore that. I was thinking about something else, but this would be my exact value for this one. All right, let's do 32. So for 32, we got cosine of 11 pi over 12. I'm going to get started by doubling that angle. So I'm going to multiply that angle by 2, which gives me 22 pi over 12. both of these numbers can be divided by 2. 22 divided by 2 is 11. 12 divided by 2 is 6. So I get 11 pi over 6 if I double the angle. So this is what I'll use in my formula. What I actually want to find is 11 pi over 12. All right, so when I set up the formula, I'll do cosine of 11 pi over 6 divided by 2, which gets me back to the angle that I want to find. Okay, so before we get too far, we got to choose, is it plus or minus? And to figure that out, I go to this angle, 11 pi over 12. So this is going to be in the second quadrant. You can either convert this to a degree and then you'll know right where it lies. But I'm thinking if this is pi, this would be 12 pi over 12, which is just pi. If I convert pi over 2, which is the 90, to be something over 12, it would be 6 pi over 12 here. Now 11 pi over 12 is almost to 12 pi over 12. It's not past it yet. So this angle will be somewhere in the second quadrant. More specifically, it'd be about like right there. But that doesn't matter. I just need to know it's in Q2. Okay, so I choose my sign based on this, not on 11 pi over 6. So I'll just make a little note. 11 pi over 12 is in quadrant 2, so cosine of the half angle is negative, because cosine is negative in the second quadrant. So I'll choose the negative option. Then I'll do the formula. Cosine theta, and I'm doing cosine of 11 pi over 6 plus 1 over 2. I'm probably going to run out of space on this one. Cosine of 11 pi over 6. Over 6 is a 30. Cosine of the 30s is root 3 over 2. So 11 pi over 6 is here. The x coordinate is 3 over 2. So that's the exact value I'll put in. So negative, I'll do the square root. I'll go back and put the square root in there in a second. Positive, actually. I don't need negative there. Plus 1 over 2. I need a common denominator for my 1, so I will change it to root 3 over 2 plus 2 over 2. Still divided by 2, all under the radical, and this is negative. I can't combine these two, but I can go ahead and multiply the two denominators together to give me 4. So what I have is negative root 3 plus 2 over 4 inside the radical. And then just like last time, I can do the square root of 4 and change it to 2 to get my final answer, which would be root 3 plus 2 inside the radical all over 2. And my answer should be negative since I'm in the second quadrant for cosine. All right, so let's do 33. 33, half angle for tangent. We want tangent of pi over 8. So pi over 8, I don't know that exact value, so I need to use the formula. We're going to use half angle formula. So I'm going to double this angle. Pi over 8 times 2. I can go ahead and reduce those to 4 and 1. So I would get 1 pi over 4, which is the 45. So when I go to use the formula, I'm doing tangent of pi over 4 over 2. So before I go too far, and actually we don't even need to use this because tangent formula that I use, the third one, you don't have to decide on the sign. But if pi over 4 is in the first quadrant, this smaller angle will be less than that, so it's also in the first quadrant. So I would choose the positive outcome if I was doing the other formula. I'm just doing the last one, so I don't have to worry about choosing what my sign should be. So I'm gonna do this formula for tangent. I get 1 minus cosine of pi over 4 divided by sine of pi over 4. So pi over 4 is the 45. At each one of these angles, the coordinates is the same. Sometimes the sign matters, but changes. But in the first quadrant, both of these are root 2 over 2. So I'm going to go ahead and put that in. 1 minus root 2 over 2 divided by sine of 45 is also root 2. I need a common denominator for my 1, so I'll change that to be 2 over 2 minus root 2 also over 2. So I put them under the same 2. This is divided by the square root of 2 over 2. Now, since this is a fraction, I can't just boom and go here. I need to multiply by the reciprocal. I'll come to a new line to do that. So I'll keep the top part, 2 minus root 2 over 2. I'll multiply by the reciprocal of the denominator. So I'm going to flip the denominator to be 2 root 2. These 2's cancel, and what I have is 2 minus root 2 all over root 2. Now, I can't reduce these two. One of these aren't the same numbers. This is 2, and this is the square root of 2. Completely different numbers. I can't reduce these two because this isn't multiplication right here, so this one isn't by itself. So if I cancel these two out, the answer is not 2. This is 2 minus some decimal number divided by some decimal number. So I can't reduce anything just yet. I do need to rationalize it by multiplying by the radical in the denominator, which is root 2. And this part I have to distribute. So I'm going to distribute this one here, and let's see what we get. So I got 2 times root 2, which is 2 root 2. And then I have negative root 2 times root 2. I'll write it out. That's going to be negative root 4 over root 2 times root 2 is just 2. And then this becomes just 2. The square root of 4 is 2. So I get 2 root 2 minus 2 all over 2. So now, this one's different from this one, because this one didn't have a factor of 2 that you could reduce with. This one has a factor of 2, so all of these have a 2. So these 2's cancel out this 2 to be just 1. So our answer that we end up with is root 2 minus 1 over 1. So I'll just leave it as root 2 minus 1. All right, last one. 34. We want to do tangent of 105. I'm going to go ahead and double 105. 105 isn't on my unit circle. It's 15 larger than 90. Not on my unit circle, so I'm going to double it, and I get 210. 210 is 30 more than 180, so this is the 30 in the third quadrant. So I care about this angle though. 105 is greater than 90 but less than 180. This angle is in quadrant 2. So I'll choose my value based on the quadrant 2 angle. Now in quadrant 2, we want to do tangent. Tangent is negative. Because you have a negative x and a negative y, when you divide those two things, you'll get a negative number. So tangent is negative. So 105 is in quadrant 2, so tangent 105 is negative. Now, if I was doing this first quadrant, I would have to choose the negative option. We're going to do this one. Let's see if we get a negative value. All right, so what we're doing is tangent of 210 over 2. So I follow the formula. I got 1 minus cosine of 210 divided by sine of 210. So like I said, 210 is a 30, so cosine should be 3 over 2, sine should be 1 over 2. So 210 is here, cosine is negative 3 over 2, sine is negative 1/2. So 1 minus negative 3 over 2 divided by negative 1/2. I go down, tight on space up here. So subtracting a negative, this will become positive. And I need 1 to have this denominator here. So I'm going to rewrite 1 as 2 over 2. So 2 divided by 2, that's my 1. And then I already had plus root 3 over 2. So I just put it as the same 2. This is all being divided by negative 1/2. I'll keep 2 plus root 3 over 2. And I'll multiply by the reciprocal, which is 2 over, I'll say negative 2 over 1. So I got to distribute this 2. Or actually, it cancels out. Sorry, I didn't even notice that. So you could distribute and then you cancel out, or I could cancel out now. So 2 divided by negative 2 is negative 1. So I need to distribute this negative 1 to both terms. So negative 1 times 2 is negative 2. And then negative 1 times root 3 is negative root 3. And then I said this should be negative because it's in the second quadrant. A negative number minus a negative decimal will still be negative. So I will get a negative number for this one. All right, so this is your review for the study guide. The other answers are on part 1. Obviously, the test won't be this many questions. I know this seemed like a lot of work, but these last ones were like 3 questions in one. I hope if you watched the video to this point, it helped you out. Let me know like if there are any mistakes, because I was kind of doing this kind of fast before my planning period ends. So let me know if there are any mistakes. We'll try to correct it in class. It's likely I made some because I didn't check and I didn't use a calculator for the most part, and I didn't use the unit circle. So just let me know if something doesn't look right. Don't stress out if something feels wrong. It's a good chance you could be right. I just made a little quick lazy mistake. So let me know. Hope this helps. Good luck. I will see you guys soon.